Hello and welcome back, everyone. This is the 19th problem in the AP Physics C Mechanics multiple choice test. This is just kind of a random test I was assigned, and we're going to go through all the problems. So this is the third set in this problem set relating to this scenario, which I'll read quickly. A solid disk of mass m and radius r freely rotate horizontally in a counterclockwise direction with angular speed omega about a vertical axis through its center with negligible friction. The rotational inertia of the disk is 1/2 mr squared. An identical disk is suspended at rest above the first with their centers aligned. The second disk is dropped onto the first disk, and after a short time they rotate counterclockwise with the same angular speed omega final. So problem 19 says the two disks are now shifted so that the axis of rotation so that the axis of rotation goes through a point on the edge of the disks. The rotational inertia of the two disk system is now A 2 mr squared, B 3 mr squared, C 4 mr squared, D 5 mr squared, or E 10 mr squared. Alright, so the concept this problem deals with, this problem was made exactly to express this one pretty small but also very important concept in the test, because if you know that concept, you will get this question right, or ones like these, every single time. That is the parallel axis theorem. Parallel axis theorem. Remember this, folks. This says if you know the moment of inertia I of the center of mass, then you can find the moment of inertia for any point of rotation, for any axis parallel to that or on the same object. So you add md squared. So what this is saying is, let's look at this diagram, for example. If we know the moment of inertia for the center of mass, which we do, it's 1/2 mr squared, then we can solve for the moment of inertia for where this axis is moved to any point parallel. So we can move it to here. We can move it to the very edge. We can move it wherever. We can even move it like all the way out here. I'm not going to draw on my wall, but we can move it all the way over there. Just examples. So what we're going to do here is we're going to take the moment of inertia of the center of mass that we've been given for one of these disks, which is 1/2 mr squared, and we're going to add md squared. So what d is in this case is the distance from the center of mass to our new axis. And here the axis is shifted so it goes through a point on the edge of the discs. So that is this case right here on the edge of the discs. So that means our distance is just going to be r, because the radius is going to be between the center of mass and that point on the edge of the disc. So plus m r squared. So let's add these right now. This adds to 3/2 mr squared, but that's not it, because we have to remember that we're being asked to find the rotational inertia of the two disk system. We just found this right here is the rotational inertia for one disk, for one of these disks, when the axis of rotation has been moved to the edge of the disk. So now we're going to multiply this by 2, add another disk. It's the same thing, but we're going to multiply this by 2 now to get what we want for the two disks that are in place. So You just cancel out. It's 3 mr squared. And that's our answer, B. So again, if you know the parallel axis theorem, which you should memorize this. This is important right here. Then this problem is easy peasy lemon squeezy. One thing that you can make a mistake of is multiplying by 2 here. Like if you multiplied this by 2 and then you added, you would get 2 mr squared. Don't do that. Don't multiply by 2 here. You're going to want to wait until the end to do that. Because you want to find like the moment of inertia for the disk individually and then add them together. That's just the way you do it. So thank you for watching. There's our answer. Let me know if you have any questions about the parallel axis theorem, rotational inertia, any of these things, rotational velocity, rotational acceleration, all of these things. Thanks for watching, and check back in for the next video, question number 20.